Hi, I'm Kathy Levinger. In this lesson, we're going to look at scale of a graph, or graphs which have unusual scales. Let's look at an example. Here we want to determine the slope of the line graphed below, and we want to attach units where appropriate. What we see is a line that hits its vertical axis at 45 degrees, which are the units in the vertical direction, and its horizontal axis at 2 hours. So that's the point where it hits the horizontal axis. The slope is its vertical change over its horizontal change. To get from the point on the left to the point on the right, I'm going to have to go down 45 units and to the right 2 units. So the slope is negative 45 degrees, let me write that word in, over 2 hours. And we should divide that, negative 45 divided by 2 on a calculator, comes out to negative 22.5. That's the slope of the line, but we'll call it degrees per hour, attaching the appropriate units. Let's try another. Here we want to determine the slope of the line graphed below, and again attach units where appropriate. And here we can see that the line hits the vertical axis at 0.001 minutes and extends with positive slope to the right. We need to pick another point on the line that's convenient to use. Let's use a point maybe right here that corresponds to 0.03 rotations and maybe 0.003, or it's close to 0.003 minutes. So I'm going to label it 0.03, 0.003. Now the slope of the line, according to the points I've chosen, is up 0.002 minutes, maybe I'll write that word in, and to the right from 0 to 0.03 rotations. Now dividing those two numbers on a calculator, 0.002 divided by 0.03, we end up with 0.0666667. Remember, you can change that to a fraction with the use of a calculator. 1/15 is a little more convenient to write. Let's say that our slope is 1/15 minutes per rotation. Kind of an unusual set of units for that one. Let's try another. This time we have some information given in table form. This time we want to find the equation of the line in slope-intercept form for the set of data given, and then we want to sketch the graph of the line. T is time in seconds, and v is the velocity in feet per second. To find the equation, the first thing we're going to need to do is find the slope. To find the slope, let's take a pair or 2 sets of ordered pairs. I'll take the first 2 and find 67 minus 3 over 2 minus 0, or the difference in the dependent variable values over the difference in the independent variable values. 67 minus 3 is 64, divided by 2, and that comes out to 32. That's the slope. Now looking back at my table, I know my vertical intercept occurs when the independent variable is 0, so I can see that the vertical intercept is 3, and write the equation of the line, v equals slope times independent variable plus vertical intercept. And now I'm ready to draw the graph of this particular line. So let me draw a coordinate system. And then I can draw my graph. I'm going to label my axes t and v, because those are the variables used in the table. And I can see that the times in my table are things like 0, 2, 5, 7, so I can use tick marks representing 1 unit each in the t direction. the v values, and actually the slope, which is 32, or 32 over 1 if you like, you can think of it as a vertical change of 32 over 1, is a little awkward if I use tick marks representing 1 unit. So I'm going to set up my tick marks in my vertical direction as 20s. So there's 20, 40, 60, 80, 100, and each of these are in feet per second. So let me indicate that by my velocity. My time is in seconds. And now I'm ready to graph the line. The vertical intercept is 3. Now that's very close to 0 if my vertical scale is in 20s, but I'll put a point there. The slope of the line is 32 over 1. So from here I want to go up 30 units to the right 1 unit, and I'm going to estimate that that's about right. Remember, each block this size is 20, so I went a little bit more than a block that size, and I'll draw the equation of the line through those points. Well, let's look at an application. The area A in square feet of a 26-inch wide rectangular garden is related to its length L in inches by this equation. And what we have is A equals 0.180556 L. L is in inches, the area is in square feet. The first question says, find the area of a garden 2 feet long. Well, if we're going to use this formula, we can't use 2 feet for L. We have to use 24 inches. The units on L need to be inches. So the area then will be 0.180556 times 24. And let's calculate a number using a calculator. 0.180556 times 24 is 4.333344. Let's round our answer to some convenient amount. 4.33 square feet. Well, question B here says we want to find the length in inches of a garden with an area of 8 square feet. Well, the A in the formula is square feet, so we can immediately put 8 for A, and we solve for L by dividing by 0.180556 each side. Now, using a calculator to do the division, we're going to find on our calculator 8 divided by 0.180556. We get 44.3 for L, and that is already in inches as requested in the problem. Well, in this section we've looked at graphs with unusual scales and applications. Be sure to work lots of exercises from your textbook for practice.